Welcome to my channel. Today we're going to study this very important concept that is basic trigonometry. Now, whenever I talk about trigonometry, that means I'm dealing with triangles. So, in this certain topic, we're mainly going to look into something that is a right angle triangle. That means whenever I say that there is an angle which consists of 90, there are two things that should pop in your mind. When you see a 90, the first thing you could apply could be Pythagoras. And the second thing that you could apply is something we call as the SOH CAH TOA rule. SOH CAH TOA. I would like to put the emphasis on TOA because I've seen many students, they actually spell this wrong. They somehow spell it as TAO. If that is the case, then unfortunately your answer is going to be wrong. So I would expect that you should know that it's going to be SOH CAH TOA. Now, what does that mean? When I say the word S, this S over here stands for something that is known as sine, or perhaps sin in short. Sin x or anything is equal to O, which represents opposite, over hypotenuse. This is one, I would say, trig function that we have. The word I'm using is trig functions, trigonometric functions. In a similar way, this C over here means that's going to be cos of x. A represents adjacent. And then again, H represents hypotenuse. The third one has to be tan x or tangent of x is equal to opposite over adjacent. Now, what you need to realize in all these three trig functions is that they're actually available on your graphic or on your graphic calculator and the scientific calculator. Right now, I'm just going to talk about fx9 and 1 ex or es. That's the scientific calculator. So you can probably see, on your calculator that it says sin, cos, tan. So those are what we call as the trig functions, trigonometric functions. Now, there is one important thing that you should understand. So when I say the word x, that means this has to be an angle. So this angle could be something that is inside. Now, let's say this is my x over here. So when you look at this x, what's opposite to this x? What's facing this x? Which side is facing this x? Can I say that's this one? Which means if I talk about this angle, this is the one that's opposite. In a similar way, remember the definition of hypotenuse. It's going to be always opposite to 90, regardless of where the angle is. That means this has to be hypotenuse always. And there's only one side left, that is this one, which is going to be adjacent. Now, there's one more thing that I'd like to clarify, that is, many students think that hypotenuse is also adjacent. What does the word adjacent actually means? The word adjacent means right next to you. And that is true that hypotenuse is also right next to that angle. But that's not how we take it. So remember that there is a fixed convention that we have. Whenever you see a 90, without any doubt, you should be able to see that's going to be hypotenuse always. This cannot be adjacent. This is going to be. I know technically it is, but that's not how we look at it in a certain question. In a very similar instance, I might ask you, what if my x or the angle lies over here? Now, again, this is also very interesting because now we have this side which is opposite. And similarly, like I said, without any doubt, opposite to 90 is hypotenuse. Excellent. And this right here, the one that is right next to this, is going to be labeled out as adjacent. So I would expect that whenever you see a 90, you should know this basic rule of SOH CAH TOA. There's also another way of doing this, which is something we call as some people have curly brown hair through proper brushing. I know what I just said may not make sense to some students. You can search this up on the internet. What I'm just trying to tell you over here is that there is another way to solve other than using the SOH CAH TOA rule. Will I encourage that? Absolutely not. Those of you who are used to using it, that's fine. You can continue using that rule. I personally believe if you use SOH CAH TOA, I can guarantee you that you won't get any question wrong in terms of finding the angle. So now that we have done the rudimentary concept, we can now just dive into some questions. So let's say let's say this is a right angle triangle. I'm already defining this. And let's name this triangle as ABC. So let's say this side is A, this side is B, and this side is C. Now, in this case over here, I'm asking you, what's angle A? So I'm asking you, what is angle A, given that this side is perhaps maybe 4, and this side is 16. Or perhaps, yeah, that sounds all right. Now, in this case over here, the question is, what should I use? So there are three properties that I just did. There are three trig functions that I've described: sine, cos, and tan. What's given to you? So let's start by asking what's given to us in the question. I can clearly see opposite is given. And what do you call this side? Hypotenuse. So which one should I use? Opposite is given and hypotenuse is given. That means I can say sine of angle A. You can write it down in this way. You can also write it down as x. You can also write this down as BAC, because the angle is something that's formed in the middle. Again, this part is not really that important. You can just say sine of x is equal to opposite. That means opposite will be in my numerator. So that has to be 4 in this case. And similarly, the denominator has to be 16. Now, once you plug in this, I would expect that you move the sign on the other side. Why? Because I'm asking you, what is this angle? And you haven't figured out the angle yet. So I need to isolate. I need to find x. What should I do? Take the sign on the other side. What happens when we move stuff on the other side? So it kind of, as in we just take the reciprocal on the other side. That's what happens. Or in other words, we say that that value goes on the other side and becomes inverse. That's exactly what's happening. Now we'll say that it's going to be x equals to sine raised to the power minus 1, which actually means sine inverse 4 over 16. I can now put this in my calculator. If I did, this should end up giving me 14.47, blah, 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 blah. Now, when it comes to angles, there's a very fixed convention that we have, and that is in O levels and IGCSE, we round this to correct to 1 decimal place. That means I can write down my answer as 14.5 degrees. Before I continue, there's one small thing that I would like to clarify, and that is you should be able to get this answer correctly. And there's one way to ensure. So no matter what kind of calculator you're using, whether it's EX, ES, this is your calculator screen. On your calculator screen, you should be able to see a small D written over here. This D is what represents degrees. And we are dealing in degrees. O levels, IGCSE, we deal in degrees when it comes to math. There's also something known as capital R as well. If your calculator says capital R, that means it's not in the correct mode. So you would have this in capital R if you're doing A-level math or perhaps add maths. So I beg you, please convert this into degrees before you start doing this kind of question. Now, again, that's just the basic gist so far that we have discussed. I'm going to be solving more questions like these as well. But before I do, let's try a practice exam paper question. So this over here is a question over here, and it says ABC is an isosceles triangle with AB is equal to BC. And similarly, AC is given to us as 32. Using as much information from the table as is necessary, calculate AB. Everyone, there are 3 types of triangles that we have. The first kind of triangle is what we call as an isosceles. So I'm just going to label this as isosceles triangle. In a similar way, the second kind of triangle that we have is known as an equilateral triangle. Equilateral triangle. Generally. And the third kind of triangle that we have is what we call as scalene. So when it comes to an isosceles, there are certain rules that you should take into account. In isosceles, we generally say 2 sides are same. And similarly, the inner angle is also equal, as in they both have the same angle. That means if this was 40 degrees, without a doubt, you'll say that's also 40 degrees. In a similar way, when it comes to an equilateral triangle, that means all sides are equal and all the angles are going to be 60 degrees. 60 degrees, 60 degrees, 60 degrees. This dot that you see on top is what represents that degree symbol. In a similar way, when it comes to scalene, all sides are going to be different. So I might as well have this as 5, 6, 7. And similarly, the angles could be, I don't know, 21, 42, whatever. I don't care. All I'm just teaching you over here is the very basics as to how these triangles, they look like. And secondly, what you need to realize over here is that we can actually, whenever it comes to an isosceles or an equilateral triangle, we can divide this into a right angle triangle. So this right now is not a right angle triangle. This over here is something that is, it's an isosceles triangle. I can say that's 80 and that's 100. But if I were to bisect, the word I'm using over here is bisect. In math, it means equal halves. If I were to cut this exactly in half, what's going to happen? So if I were to erase one part of it, that's how it looks. And we can say this angle divides in equal half. And this right here forms a 90. And you can add this up. So you do know that the sum of a triangle is 180. 50 plus 40 plus 90 gives you 180. That means this is a right angle triangle. This is exactly what we're going to incorporate in this question. Why? Because this is something that is a paper one question. In paper one, a calculator is not allowed. That means we should be doing something without the use of calculator. So like I said, in isosceles and in equilateral, we have the option of dividing a triangle in equal halves. That means I can make a straight line over here. Does it have to be a really straight line? Not really. I'm just doing this for our own understanding. And we know that this has to be a 90, as in the angle that forms over here is 90. I just said that the length is also going to get divided in equal halves. So what's half of 32? It's going to be 16. That means, everyone, this side over here is 16. Now think about it. Ignore this for a while. Ignore this triangle that we have on this side. What are you going to use? And what are they asking us? They're asking us to find AB. Which side is AB? This one. What do you call this side? What did I just say? Whatever is opposite to 90, what do you call it? Hypotenuse. Excellent. And if that's the angle that we are dealing with, if that's the angle theta that we are dealing with, what is this 16? Can I say that's right next to it, which is adjacent? So what should I use over here? Can I say cos of this theta is equal to adjacent over hypotenuse? Now, in this case over here, what's adjacent? Adjacent is something that is given to us as 16. And what's hypotenuse? Well, that has to be AB. I'm just going to call that as AB, the side AB, what they're asking us. Am I familiar what cos theta is equal to? Yes. That means cos theta is equal to 8 over 17. Which means, everyone, in the next step, you can actually replace this cos theta as 8 over 17 is equal to 16 over AB. Now, all we have to do is just cross multiply. If I move this on this side, 8 in the denominator, 16 over 8 is 2. 2 times 17 is 34. So I can say AB is going to be 34 over here. That's it. A question that I usually get is, why did you divide this 32 in half? Why can't we take this thing as 32? Why is 32 not adjacent? Everyone, I said the rule of SOH CAH TOA is applicable when it's a right angle triangle. So when you look at this triangle, it's not, this is not a right angle triangle. There's no 90 in it. If there's no 90 in it, you can't do that. So in order for me to solve, I had to divide the triangle so that I have a 90. Having this 90 allows me to use SOH CAH TOA. Otherwise, we can't do that. So I hope you get the basics as to why we are doing it. And why did I just take the left side? Because the left side has the theta. Will it not be the same over here as well? Yes, of course, it's an isosceles. Both sides are going to be theta, but I chose the left side. You could have chosen the right side as well. Again, it doesn't make any difference. So I hope you get the basic gist of this concept. We'll continue this, hopefully in the next lesson as well. And you'll see me giving you some very basic rules. There's an important rule that we have for sine and cos. Anyways, we'll continue this in the next lesson. Till then, adios.